Well, not quite. I was asked to give a summary talk, and it is in some ways a summary, but obviously we've covered a lot of ground already. So I'll try not to dwell on things that we've already talked about, although you'll see that some of the slides are in there because I prepared it a while ago. But I've added some more things, and we can focus on those later. Just to step back, just a reminder, we have actually been attempting to do or doing multi-messenger astronomy analyses with LIGO data, LIGO and Lion Virgo data for a while now, beginning with what we call externally triggered searches, and in some cases joint searches with exchange of trigger information, looking at candidate events. And over the years, we've actually done this now with, certainly in many cases with GRBs, but also a variety of other kinds of astronomical events to look for these kinds of candidates in coincident ways. And then we also initiated an EM follow-up program, which, well, you know what that is. It looks like this. The count is now 92 groups that LIGO and Virgo have signed MOUs with, mostly electromagnetic, a couple of the neutrino groups. So it's really an impressive number of different groups who are, with all variety of capabilities, who are interested and more or less available to contribute to being the recipients of these alerts here. Our goals, as this won't surprise you, our general goal is to identify candidates as quickly as possible with basic information, including a sky map and some amount of classification, event parameters, and to provide rapid alerts to observers. But always keep in mind that although our goal is to provide rapid alerts, it doesn't mean they need to be used rapidly. In many cases, this is just useful to correlate with surveys which are already ongoing. And in some cases, the follow-up observations triggered by this may be prompt, and in other cases, they may be delayed by necessity or by appropriateness for the kinds of signatures that we're looking for. So, although we've put a lot of focus on minimizing that alert time, remember it's not essential for everything that one can do with this. Anyway, what we can enable, obviously, pick out interesting events. Even if there's some uncertainty about what's real, prioritize the resources that are available to follow this up, and maybe catch a counterpart that would have not been identified, or catch a counterpart that would have been identified eventually, but catch it sooner so that we can get more information. Maybe deploy some more observing to follow that and really characterize that well, and to get information of in different colors, different energy bands for photons to stitch them all together and determine what can happen in coordination with the gravitational wave signal that we're also getting. You know that we've done this for O1. I think what was really interesting, that even for that very first event candidate, and it was just a candidate at first, and we said very weak things about it to all of our observing partners, and yet we had 24 different groups followed up, some expending an amazing amount of effort on this event candidate. And lo and behold, nature was very kind to us, and we should be very thankful to nature that it turned out to be real. It didn't have to have gone that way, as far as we knew at the time. So there is the enthusiasm there and the involvement. Not every one of our partners has followed through with making observations, but that's okay. Plenty have, and overall I think we are capable of learning a lot. It is publicly announced that we've shared 6 triggers with our observing partners this run so far. And just as you probably realize, but just to emphasize, that does not mean that these are all real events. I will even hint to you they are not all real events. They were selected with loose criteria and so on, but that's what we plan to do. The information, like the estimated false alarm rate, was shared too. We are trying to do an even better job of providing the context and interpretation of how good of an event candidate is it, whether it's marginal, whether it's more highly confident. Because we know that this false alarm rate is not the same thing as the p astra we've been talking about, the probability of it being astrophysical in some model. Yeah,
Peter,
sure.
can the 6 triggers, could they include an injection event?
They cannot include an injection event. We are not doing blind injections anymore.
Okay.
Yes. I hope we've made that clear enough. Yeah. Okay, yeah.
Is it,
We're all very happy that we're not doing
is the blind injection channel blocked?
we have deleted the software to do blind injections, basically. Yeah. We have taken the computer that used to do the blind injections and we're using it for something else. We have not gone in with wire cutters yet, but you know, it's all right. And the basic classification, we aren't on this at this point providing detailed classification of mass parameters and so on, but we are at least trying to provide as much as we can summarize of the likelihood that a neutron star is involved. That's the key thing that people are mostly interested in, that and whether it's a merger or not. That we can say. Yes, you know about this. Well, okay, so how will this improve? We were just talking about this. I won't dwell on this. Yeah, the three-dimensional thing. There is this large ambiguity with parameter correlations with sky position and distance in particular. So with two detectors, where we have arcs into the two-dimensional sky and therefore petals in the three-dimensional sky, in some sense, we have a large ambiguity. But if we can, with a smaller two-dimensional localization, that will really, you know, whether it's carving out this slice or this slice, this pencil, we'll have a better handle on the distance as well. And we can get somewhat better information about other parameters, I think, in general sense. Okay, so one key thing, speed versus quality. So this is something we're already dealing with. The analysis and the sky map construction are already pretty fast. A minute or less for CBC and a few minutes for burst candidates. As I think we've talked about, we're actually sending out alerts with latencies of tens of minutes, say 30 minutes when things work reasonably smoothly. And in some cases, it has been substantially longer due to one or some technical issue or another. This is dominated by the human checks, and what we have found so far in the data that we've collected is that many triggers have been produced from artifacts that we are able to examine and reject. In fact, you know, the majority of the times that we get awakened during the night to look at some potential candidate, we reject it before it even gets shared with observers. We have set up a system, in principle, we've envisioned a system for sending preliminary alerts without the human vetting and then following them up with a vetted version or a retraction later. And we still envision doing that, okay, but we're not doing it at the moment. But in any case, these would be clearly indicated. One of our hesitations now, so you know, any observer can select based on whether it's vetted or not. It's more important for some than for others to have the lowest possible latency. But a question is, are all the observers prepared to make that distinction and observe only the ones which, you know, to choose the level of quality that is appropriate for what they're doing. And if we send a retraction notice, something that we've tested internally at some level, but we haven't shared that with observers, are they going to recognize that and be able to cancel observations or whatever? Another question is just how valuable is the speed? One issue, you know, these checks that we're doing manually now that take tens of minutes. Yeah, anything can be done in software, right? We don't currently have a clear framework for automated, even the things that, the known problems that have been encountered so far. And it's not that there isn't a framework, there are maybe a couple different ways it could be done, but there isn't a clear way to test and insert an automated check each time we learn something new about the detector. So I think this is a challenge that we have to try to face. if we want to improve our analysis and automate these kinds of checks as we learn about them. Also, for some counterparts, every minute counts, maybe even seconds count, but certainly a minute counts here. And my favorite example of that is it would be great to catch the prompt radio emission from an event. Prompt, but dispersion delayed, so that it arrives a minute or 10 minutes later, depending on the frequency and the DM, in other words, the amount of the electron density it has to travel through. And for those observations, every minute really does count for catching that, initially synchronously emitted radio pulse. But for many plausible counterparts that we're talking about, 10 minutes is probably fine, I think. For some counterparts even more. And here's an interesting thing. For any given gravitational wave counterpart, the chance that LSST will be immediately able to observe it is something like 6%. Okay? That's LSST spends maybe 6 hours on the sky. I don't know what the average time, but
8 hours per night, but at any one moment, about 5 hours are accessible.
okay.
Already.
Okay, and it's seeing a quarter of the sky with decent air mass and all that. So it's something like this. So this is something to keep in mind when we're talking about rates, that only 1 in 16 event candidates will be immediately observable by LSST. Now, but immediately observable. Okay, fine. That's looking for really fast decaying things. But these kilonovas, these off-axis afterglows we're talking about, that's okay. It's okay. I don't know what the number is. Yes?
Honestly, what I look at that is, oh my goodness, 1 in 16 events would be immediately observable by LSST. That's pretty cool, actually.
Oh, absolutely. It's cool.
Yeah. Because you could get lucky. It may take 2 years, but if you have enough events, you might actually catch some prompt optical thing that's been newly predicted that you would have never observed otherwise. So that's actually pretty cool.
It is pretty cool, but it also, and another feature is that even when we have a large, what we think is a large, regular rate of binary, neutron star binaries or something like that, LSST won't have to be deployed immediately for that many of them. It'll still be, it's not like every week, probably.
Yeah.
So anyway, I don't know what the number is exactly. I guess 25%. This is not a calculation. But something like that maybe. Obviously, the chance of LSST being able to observe something within the next 12 to 24 hours is higher as the Earth spins, and that's fine again for some of these counterparts that we're looking at. And the key thing, and it should be obvious, that the TOO strategy for LSST should depend dramatically on how quickly it can get onto the sky at the relevant place, so somebody should work out what that is. But I think whether it can immediately observe or whether it can observe 1 hour later or whether it can observe 8 hours later or whatever, probably the TOO strategy will be substantially different for those cases. And if it can't observe till 18 hours later, it might be, I don't know. Okay. Another thing about this is that clearly, the LSST TOO capability, which is not the only way that it helps, obviously, but focusing on that right now, it's going to need to involve other facilities, and so that's going to have to be worked out how it will involve those and at what stage. And so those the strategy, it's got to be semi-global or semi-global strategy in terms of what facilities are going to follow up and whether LSST can follow it up or not.
This is a critical point that LSST would be used only to identify candidates, and the deal is to hand these candidates off to spectroscopic facilities as soon as possible. So there's a constraint. Our backs against the wall here in terms of timescale. We can't afford an exploratory program to find candidates that last longer than a day for many of these sources.
If it's something peaking in a day. Yeah. That's right. So that's all got to be arranged, and you know, who and what will be done to arrange that, to line these up. That's going to a critical part of it, of succeeding here. It's going to partly depend on the time scale of the counterpart. I mean, also, so whether it's a 1 hour thing and you want a spectrum within an hour, or whether it's peaking 12 days later, and
But that won't affect planning.
right, we won't know it. Yeah, yeah. So initially, we're going to need to cover all these bases.
Right now, at least, and things will improve. There are two candidate signals. One on a time scale of an hour, and another one of a time scale of a week. The one which is on a week is by definition infrared, and it's much dimmer. And for this, you cannot scan large region in the sky because there is no facility. And the one in the so it's very important to try to catch the first one.
Okay, so I don't know if everybody heard that, but let's be saying that basically you're saying I think we should be focusing here on trying to catch the 1 hour time scale transient.
Because if it is there, it is strong, and it's in the optical or optical or UV, so it is easy to detect.
Okay, that's fair.
But it's short. And the best bet, actually, in my mind, to discover the signals is to catch an idea where it could be, and then to scan it later on with deeper facilities, because now you have a week, and to identify which one of these candidates was the IR. That's my idea of how this should work out, and I don't see another possibility.
So you want
at least from what we understand now about these signals.
So you want to find both of them, but you find the first one
No,
with...
I think that the second one cannot be found without the first.
Okay.
So I would push back a little bit. I mean, I agree with Pete that we're thinking about that we have a few ideas for these hour-long transients, but there may be components of the ejecta that aren't as neutron-rich. Even in the cases where you have these infrared transients, in the optical bands, they peak on daytime scales. They're very dim, potentially, depending on exactly who the capacities you agree with. But I would say I still think there's a value to having observations on daytime scales. But I agree with Svi that it may be the case that the hour things are as promising or more promising. So I think we should cover both bases. I don't think we should look at it for an hour and then not look at it for a week. That's my only point.
No, I agree, but I think that the trying to look at the first hour is very
It's important. Yeah.
You shouldn't disregard this as well. We cannot do it, so we'll forget about it.
I just wanted to interject that ideally, step one would be, assuming we have a binary neutron star fluorescence, an X-ray signal.
X-ray signal would be beautiful, yes.
It would be beautiful.
Yes.
It would be narrowing down all the research area for LSST and other optical infrared telescopes.
Right. Okay, I don't have much more, but let's...
Well, I was going to say, will there be a talk about, I know this is LSST, but will there be a talk about planned X-ray emissions and how that might integrate with timescales?
Just, I don't know
Yes,
if
okay.
there is a talk there,
Okay,
but...
Thank you.
Good.
Good.
But basically, we haven't done X-ray. Are you going to talk about?
Yeah, I got a paper for that too.
Because I have the slides from Jordan as well.
Okay, good.
So the coordination wasn't exactly ideal. But yes, I'll be going and give a talk, but I would say that I was going to talk about it if we actually had been informed by NASA headquarters this mission is selected. And you're part of the mission as well, and so is Leo. But the question is, the plans are there. It's the mission to go at 2021 to do the observation of short gamma ray bursts. It's a night sky monitor. Ralph is going to talk about it. But we haven't heard from headquarters whether it's selected yet. So it's a plan, but definitely not adopted. Just
Right, yes. We're doing that. Okay, I won't say much more, but we will issue public alerts likely at the beginning, starting at the beginning of 03. This does not mean that all candidates will be public, only the high confidence ones. At the moment, we think those are the ones that are 1 per 100 years and have no other reasons to doubt them here. We will still be identifying and sharing the other candidates, and even the ones that will be released publicly here, this is not going to be that fast. I would guess within an hour or so, and it will be through a public circular. But to get the minute-ish latency or whatever it is out, that's still going to be part of the internal thing. But that's not a big deal. We can arrange that. I think, roughly speaking, I think the desire expressed by Tony is that the ones that LSST will follow up are high quality, maybe basically what we put out for the public. But where exactly to draw that line, we can work out. It may depend on rates and perception of cost and so on.
So that's an important point, because we are an open public survey. That means we don't make private deals. We've been approached by a number of people to make private deals. The board has decided against it.
Okay.
So we would have to make use of both.
That's interesting. Okay, I hadn't thought about it in terms of even receiving private information. So, but you also don't want to wait an hour until we issue a text circular.
We need information after as soon as you can get, like a minute would be great.
Yes, and that's not.
Is an exception to the rule that it will be made public in 59 minutes? I mean, like you know what I mean?
Yeah.
Like private
I
initiatives.
suspect so.
Okay,
Yeah.
that would be
Yeah.
helpful.
I don't know for sure.
That's a good point. Hadn't thought about it that way. Okay, good. And one of the things I think would be great is every time there's a public alert, at that time there could be the LSST, force photometry. I don't know, something like that for the location. I can imagine. Since I was making this slide, that LSST and potentially other facilities, but especially LSST, could be prepared to provide supplementary information along with the announcement of the event from the gravitational wave point of view. All right, that's basically it. Capabilities should get better, the speed should get faster. Discussed, what the relative trade-off is, and so on. I think that the TOO strategy should be dependent on time, both in the sense of how quickly the observations can be made, and also obviously based on what we learn about counterparts as we go. The first time we detect one, maybe the second and third times, we'll have a better idea of what to expect in the future then. I'm very interested to see how all this gets organized. I know that a lot of the challenge is this. Okay.
Any quick questions?
I had a question. So I think on one of your slides you mentioned that should we continue to have MOUs after the first 4 events are over. So what would be the advantage of, what would being an MOU partner give you after?
Well, more alerts, the more marginal ones,
Okay.
the less secure ones, and also in the immediate information.
Okay.
So those are the.
What is the reason to not make the public alerts have low latency?
At least in the past, and I think currently, the philosophy has said we don't want to put out anything that we're later going to have to say this was no good. I think that's the fundamental thing. And after we've published enough events, maybe we won't really worry too much about that. But that's where it came from.
So what's happening in that hour?
We probably will take, take an extra human look at the data quality and compose the circular. I mean, maybe it ends up being 20 minutes instead of an hour, but it's not 1 minute.
Okay. I mean, I'm not
No,
arguing
yeah.
with Cole, but even if there's a lag, there's presumably a discrete concrete plan for what you need.
Yeah. It's not that concrete yet.
If it's any help, that happens all the time. That's what, we'll have a trigger and then later we'll refresh it. And I think we're used to it, but then,
Yeah, I know, that's the thing, right, yeah.
We were paranoid at the beginning. We
Yeah.
did exactly the same thing. We
Right.
basically said we weren't going to release lab alerts promptly until
Yeah.
we felt like we had our leg under us, and then we released them promptly to some people, and then only,
Right.
eventually kind of let all things flow. Because you get, when you're first starting out, people remember a wrong thing at the beginning much more than they remember many right things until you have a reputation for having right things.
Right.
Yeah, so I wouldn't be surprised if this threshold changes from 1 per 100 years to 1 per year or something within, it probably will be more, there will be some threshold which is more selective for this than what we would be willing to share with partners, but yeah.
So, as you might imagine, the project has had a raging debate on this issue for the last 10 years. And it was simply decided that every alert that we issue comes with a health warning. Because when we issue the alert, we know a lot about the randoms rate, even the Stevenson distribution. And we can tell you how probable this is that it's real. And we can probably, the data broker probably will be able to tell you what it's likely to be. And so we decided to set it to 5 sigma. And some of those are not going to be good things, but that information would be included in the alert. And it's all public.
Yeah, that's good.
And so we bypassed this issue.
Right. Well, if we get a binary neutron star candidate, we can't tell you the probability that it's real at this point.
Okay.
So we can only tell you what the chances of our noise producing that in a.
Exactly.
Yeah.
That's
Yeah. That's. But once we get a handle on that on that population, then things should be better.
Okay, thank you, Peter.
Okay, sure.
Thank you. So we have two more topics before lunch, and one of them is Tony, and so Tony has to leave at some point. So Tony, you're up after the panel. What
Okay.
time do you have to leave?
Oh, 1:30?
1:30. Okay, so that should be. So you're fine with waiting for the panel. Okay. So let's continue with a panel on other projects, which is not LSS2 related, and let me explain in a second why that's relevant here. So Michael.